Hello, and today I would like to go over all the loop functions that VEX offers. So this will be the first part, and I think we can go straight into it. So here I have just a empty null, and I'm creating a wrangle. This function, or this code here, will create a circle with exactly 103 points. So just to keep you, or just to explain how does this work, if you set this to detail, the code will run only once, or just a single time. If you set this to primitive, it won't run because we have 0 primitives. But let's say we had 10 primitives, this code will run on each primitive, so 10 times. If you run this on points, it will run on how many points do you have separately. So just so you understand how wrangles work, they compute or they execute the code on each point separately, parallel. So wrangles are very efficient when it comes to multi-threading. So here I have the first example for a for loop. So a for loop will, generally speaking, take three different parameters. You can, of course, remove, let's say, the first one here. The code still works. Also, the last one here, and the code will still work. So, but I think it's the best, or the best choice is to always initialize them in the parameters, or in the parameters here. And what are we doing here is the for loop takes three statements. This middle one is the most important one because that determines till when the loop will loop. For example, if I remove this here, we can see that my computer is computing something, but this will compute till infinity because the loop isn't adding my y anything, and the y will always be smaller than my number of points. So I need to exit the loop. Maybe my computer crashed currently. Okay, it didn't. So keep that in mind that these loops can be infinite. So the first one is creating a variable in I which has a value of 0. Then what we're doing is we're comparing y with the points. So we know we have 103 points. So this will loop until y isn't larger or equal than 103. And this statement here means that we're adding each iteration 1 to our I, or a value of 1 to I. Of course, the reason why you wouldn't use this here is maybe you want to add a different number each iteration, but just to summarize this, I usually is used inside loops to determine the iteration you're currently on. So I generally speaking, if you want to use, let's say, a different variable like a float a that's set to 0, and let's say you want to add to float a each iteration 0.1, that's how I would go about it. I wouldn't actually do anything with the I, because the I could be very useful for determining the number of iteration or the current iteration you're currently going through. So, as I mentioned, I won't go through the code here, but this code here just creates a essentially new position for each of those points on our circle. So then the next one will be a for each loop. So as you expected, for each loop goes over for each something. So in this case, it's going to be for each component of our array here. So endpoints will give us the amount of points we have. So if I, let's say, create an integer, which will be pt count, is going to be a detail, we can see it's 103. So that gives us the amount of points we have in our stream. So this will here, it will give us an array of all the point numbers on this primitive geometry. We can see that with a single primitive, so we will get point numbers ranging from 0 to 102. So this is included in our points array. Then what I'm doing for each loop. So for each loop, this one here is a optional parameter. I'll go over it in a second. And this one here is a value or variable that contains the value of that current value being iterated through that array. So this for each loop starts and it will take the point number of 0. So the 0 will be contained inside this pt variable. Then the next iteration it will be 1. The next one 2, 3, 4 until 102. So that's how this pt works. So, and the third one here, parameter, is the array you're trying to iterate over. The index here. So, the index is essentially something similar as the y inside our for loop, it contains the current iteration you are on. So that's basically how it works. So on the first iteration, it will hold 0, then 1, 2, 3, 4. Of course, in this case, the PT and the index will hold the same value, but in other cases, you can have arrays with various values, usually not point numbers ranging from 0 to 102. So then I have just a if function. I'm just checking if the index in this case divided by 5 is is dividable by 5. And then I'm just essentially in this case, what we're doing is that we're adding to every fifth point. If you look at this, every fifth point, or point number that's dividable by 5 is being adjusted, as you can see. 40, 45, 50, that's all that code. So you can go check it out. And in here, I'll go over the while function, and I think I'll leave everything for the next part here. So the while function works very similarly. It's more simpler. So the while function will iterate until something isn't true in here. So we're saying that I created an integer set to 0, and I'm saying if the I is smaller than it, then iterate over. When I gets equal or larger than it, then we break the loop. So we know the it in this case is 90, and I'm just executing a code here which essentially adds adds a value in the y-axis, and then what I'm doing, I'm adding to y each iteration a value of 1. So what happens here, if I decrease this value, we decrease the points that are being affected by it, and that's how this works. So I think this is everything for this video, and I'll see you in the next part. Bye bye.